So today is lesson 6.5. We are finishing up our introduction to algebraic equations. We started with addition, then subtraction. Our previous lesson was multiplication, and this one is division. So as we go through it, then in the same way that we've seen this each and every time, the process is always going to be the opposite of the lesson that we're talking about. If this is division, then we have to know that we have to do the multiplication property of equality. And once again, all that means is I'm going to do the opposite function. I'm going to multiply where the variable is on the opposite side. Make sure that you have your handout because we're going to fill this out and then we're going to be able to put this into our math folder and reference it on things like tomorrow's review, as well as the other things we're going to be doing over the next several units in mathematics. So when we look at what we want to be able to do, we want to be able to see these one-step division equations that have a variable and use the multiplication property of equality. We want to multiply on the side of the variable and then multiply on the opposite side in order to solve for what the variable is equal to. As with the previous three lessons, we're going to start out with a word problem. I know, once again, there are several of you that hate word problems, but some of you just don't want to stop and think about what is being said and cube it up so you can use the important information and figure out the process that you need to establish. If you will cube it, you'll do much better. We have Cyrus, Brian, and Michael. They are sharing a pack of stickers. Each student gets 9 stickers. Write a division equation that can be used to determine the total number of stickers in the pack. Once again, it is not asking me to solve a math problem. It is asking me to create a math problem. So when I'm looking at what we're talking about, I have each student. So that's just one student. And we have 9 stickers, okay? I'm to write a division equation that can be used to determine the total number of stickers. So I know my equation is going to be division. I know we're doing algebra, so I know I'm going to have a variable of some sort. Well, what am I looking at? Well, I'm looking for what we often refer to as a unit rate when we are talking about each student. So each student is going to be sharing and they're going to be getting 9 stickers. So one student will get 9 stickers, or we can say that 9 stickers are going to be for every one student. How many students are there? We have to go back and look. So if I have students that we're talking about, we're talking about 3 different students. So when I start looking at the idea of sharing, how would we share? Well, sharing means if I have a total and I'm going to make sure that everyone gets the same amount, I'm going to take the stickers and I'm going to put them into 3 equal groups. So that's going to be an indication that we are dividing, which once again is what the lesson is actually about. What variable should I use? Well, I'm looking for the number of stickers, so we're going to use S as our variable. So when I look at it, I have stickers. I don't know how many stickers, so I start with I have stickers. I put my S. I know I'm dividing because I'm sharing them equally among how many people? 3. And I'm told then that my answer will be that they each get 9 stickers. So that equation, as you can see in your book, is S divided by 3 equals 9. I have a group of stickers. I'm going to divide it amongst 3 friends, and they're each going to get 9 stickers. Same type of problem. I have Benji rode his bike from Pittsburgh to Cleveland over the course of a 3-day weekend. His average distance was 48.5 miles each day. What was the total distance that he rode? So when I'm looking at setting up the math problem, once again, I have a 3-day weekend. So 3 days means the number 3, and I have 48.5 miles. Well, that's an average distance of 48.5 miles. So what does that mean? Well, when I look at the idea of how much I spent on each day, an average means that I'm going to have a total divided amongst the number of groupings. So average. We haven't gotten into mean, median, mode, and range yet. That's 5th grade, but we do get into it after Christmas break. So we will be looking at that. But anytime I see mean or I see average, then it means the same thing. I'm going to find my total sum. So I'm going to add them all together and then divide by how many groupings we're talking about. I'm going to take my total distance. I'm going to divide it into 3 to give my average. So division, anytime that I see average, it simply means division. What was the total distance that he rode then? I'm going to use the D to find the answer. So my variable is going to be D, and we're going to say my overall distance, D, is going to be divided by, how many days? Well, 3 total days. So what was their average? How far did they go each of those days? 48.5 days. So then we're curious as to, well, how far did he go altogether? Well, this is what we're going to add to our handout today. So get this out. You should have addition done for you, because I did it for you. And then you filled out subtraction, you filled out multiplication, and so we are going to fill in our handout. This is our last box. We have our example for addition, our example for subtraction, our example for multiplication. This is our example for division. So we're going to have our D, our variable, divided by 3 equals 48.5. Need to understand, once again, that a variable is a letter or symbol used in a math problem when I don't know what the value of the number is. I have to remember that my process is always, always, always to do the opposite function, then I do it on the opposite side. So if I know that I need to get my variable alone, and that's my step 1, then I ask, well, what is the opposite function? What function is happening to my D? Well, functions, once again, adding, subtracting, multiplying, and dividing. Adding and subtracting always go together and flip-flop. Multiplying and dividing always go together and flip-flop. And in this set of problems, we're going to be dividing. So the opposite of division is what? Multiplication. So in order to get my variable alone, instead of dividing by 3, then I'm going to multiply by 3. This is a step for some reason that many of you don't want to show. You need to show it, because when we start getting into 2, 3, 4-step algebraic equations, you're going to be completely lost if you don't show your cancellation. Show your cancellation so you know it's done and it's removed from the math problem. This allows you to get your variable, your D, alone, so I bring down my variable and my equal sign. That tells me then I have to do what I did on the left-hand side in this problem on the right-hand side. I multiplied by 3 to get rid of the dividing by 3, so I have to go to the opposite side, the inverse, the equality process for multiplication. 48.5 times 5 multiplied by 3. Well, I take my 3 and I multiply. 3 times 5 is 15. Carry my addition of 1. 3 times 8 is 24. Plus 1 is 25. Put down my 5. Carry my addition of 2. 3 times 4 is 12 plus 2. 12 plus 2 is 14. It is not an answer of 1,455 because I multiplied with a decimal. So I count my decimal spaces, once again, not decimal points, decimal spaces. How many spaces are after decimal points in my math problem? And in this one, there's only 1. I go to my answer, I move my decimal from right to left 1 time, so I get an answer of 145 and 5/10. That's my example. Please make sure that it's written down on your handout so that you can look at it multiple times as we work through this process. All right, so when I start doing the second half of the lesson, which is solving for my variable, then I look at the math problem that I have. I have a fraction that looks really weird, x ninths. I don't even know what that means. Well, you don't need to, right? Because once again, it's not making this difficult. It's just going through the process and doing the steps every single time to be successful. What type of math is a fraction? Fractions are division. So that's not saying x ninths, that is saying x divided by 9. So if I am dividing by 9, how do I get my variable alone? I do the opposite of dividing by 9, which is multiplying by 9. So if I multiply by 9, then once again, I don't have to show what that equals. I just cancel it out because it gets rid of it. It gets my variable alone. I bring down my x to my equal sign, and now I do it on the opposite side. Step 2. So step 2 tells me I'm going to take 13 times 9. Easy enough. 9 times 3 is 27. Put down my 7. Carry my addition of 2. 9 times 1 is 9 plus 2 is 11. So we're saying that x is equal to 117. Yeah. And notice that we have the x is equal to. We must have our variable and show what it is equal to. All right. So I want you to try this one. Same type of setup. Come back to me and let's check your work. So hopefully you have an answer. You see your math problem, 9 is equal to, it's not x 17ths, it's x divided by 17. You said, well, if that's dividing by 17, I know I need to get my variable alone. Therefore, I'm going to do the opposite of dividing by 17. We're going to multiply by 17. And then you showed me that you just cancel it out. Then you go to the opposite side and you multiply by 17. Got my variable alone. Now, for some of you, that gets confusing and you don't like seeing it that way. That's okay. Just change the math problem because, once again, with the commutative property, I can switch in addition or multiplication and put them in any order. So instead of multiplying 9 by 17, just switch it to where the 17's on top. 17 times 9. Easy enough. 9 times 7 is going to be 63. So I put down my 3, carry my addition of 6. 9 plus 1 is 9, plus 6 is 15. So we're saying our answer is 153. So let's look at what happens when you just do 9 times 17. Can I do math and multiplication that way? Sure can. It's just going to give you 2 steps that you have to add together. If I start with my 7, 7 times 9 is what? Well, that's 63. My second number tells me to bring down 1, 0. 1 times 9 is what? 9. Then when I add those, 3 and 0 is 3, 9 and 6 is 15. Notice you get the same answer. So you don't have to put the bigger number on top when you multiply, but I'll be honest, I do, because that's the way I like my math set up. But you need to have the answer. 153 is equal to x, or as we talked about in the previous lesson, it can be flipped around. Could be x is equal to 153. Either way is fine, as long as you have the correct answer of 153 and you have that it's equal to the variable of x. Is this what you got? If you didn't, do you know why? And if you can't see why, come and ask so I can help you. All right, so let's go through these type of problems. Well, now I have 2 fractions. I have c thirds is equal to 2 fifths. That doesn't make any sense to me. Well, then let's not look at c thirds as a fraction. Let's look at it as the math that it is, because fractions are division. So I have to get my variable alone. What am I doing to my variable? Well, my variable is c, and I'm dividing by 3. So in order to get the c alone, I'm going to multiply by 3. So if I multiply by 3, then I show that I cancel those out. And then I've done step 1. So now I'm going to take and drop down my c is equal to, and I'm going to go to step 2. I do it on the opposite side. Whole numbers and fractions. Can I do whole numbers and fractions? Yeah, if I go all the way back to Unit 3, we sure can. The only difference is we have to take our whole number and put it over a 1. Now, it's a fraction, so I can do this. But how do I multiply fractions? Simple. Multiply across. So if I multiply across, I end up with 5 times 1, which is 5, and 2 times 3, which is 6. But anytime we multiply fractions, we have to see if we can reduce, which we can't, or if we can convert, which we can because it's top heavy. So, as we talked in the previous lessons, which one goes inside the division box? The top number always goes inside the division box. So I'm going to take 6, I'm going to divide it by 5, and 5 will go into 6 how many times? Once, which gives me 5 and a remainder of 1. Since I'm starting with fractions, we're going to end with fractions, or in this case, a mixed number. So I know that my remainder is always my numerator. My divisor is always my denominator. So we find out that C, our variable, is equal to 1 1/5. That's our answer. So now I want you to try it, and you got to do a little bit of thinking on this one because there's a process that I didn't review in this lesson yet. Find your answer, come back, and check. So hopefully you looked at this as K divided by 4 is equal to 4 2/3. And then you said, I've got to get my variable alone. I have to do what? Multiply by 4, right? I'm dividing by 4, so I get rid of by multiplying by 4. I cancel it out. I have my variable alone. You should have then dropped down your K is equal to. Then you, once again, as we said in the previous lesson, you have to put the opposite function on the opposite side behind whatever math there is. So when I put it behind, I see that I'm multiplying by 4. Well, now I've got a mixed number and a fraction. Well, also in Unit 3, we talked about how we change a mixed number into an improper fraction. We start at the bottom, we multiply going clockwise. 3 times 4 is 12. Then we add. 12 plus 2 is going to be 14. I keep my denominator of 3. So we have to change that into 14/3. And now I have 14/3 times 4. Well, once again, I can't multiply by a whole number. It has to be a fraction. So now I have two fractions. I multiply across. 3 times 1 is going to give me 3. 14 times 4 is 56. It's top heavy, so I'm going to divide. 3 will go into 5 one time, because 1 times 3 is 3. Remainder of 2, and I bring down my 6. 3 will go into 26 how many times? Well, it'll go in 8 times, because 8 times 3 is 24. My remainder of 2. Well, once again, we start with fractions, so we're going to end with fractions. My remainder is always my numerator. My divisor, the 3, will always be my denominator. So we're saying that K is equal to 18 2/3. Should be pretty easy, right? Especially since this is the 4th lesson in a row where we've done the opposite function on the opposite side. Continue to think about that every time you see algebra. Once again, that algebra is going to be applied from now until you get done taking any of your math classes as you go through school. This one is focusing on the fact that I start with division, so I have to do the opposite function by multiplying where the variable is to get it alone. Then I go and multiply on the opposite side. So now that your handout is completely filled out, you have that example on paper that you can look at. I'm also going to put that on Canvas announcements for you so you can see it as many times as you need to. As you're doing your assignment, go through the process and think about step by step, because tomorrow's lesson or next lesson is going to be reviewing all 4 of the math functions in a math assignment. Then we're going to start doing 2-step algebraic equations with all 4 functions. Knowing how to do the opposite function on the opposite side is the key to it. If you have questions and you've taken your notes, come and ask.